Praveen, can you hear me? Okay, we'll start the class. We'll start the class. Okay. So we are going through theory of machines. We have already completed one lecture. The first lecture, that is your simple mechanisms, right? With respect to your HL PSU. So today we are going to do a second lecture, right? That will be of velocity and acceleration analysis. Velocity and acceleration analysis. No problem, Praveen. You can attend whatever you can understand is good. You're utilizing your time, and later on, definitely the recording will be there, so you can go through the recording later on whenever you require. Okay, okay. So let's start with chapter 2. Okay, no issue, Naveen, no issue. Right? You have class today, and tomorrow you don't have class, and again day after tomorrow. Right? Again day after tomorrow means Friday. You'll have a class on Friday, Saturday, and Sunday. Right? 3 days of class from today. Right? Today is the fourth class, second class, and 3 more class. Okay, let's start. So share the screen once again. Just hold on. Okay, we're starting with he is traveling, so he's trying to attend the class while traveling, so he's having some internet connectivity issues, so he is Praveen is coming in and going out, right? So okay, so he can attend, he can utilize whatever time he can, right? But otherwise we'll go through the class. Okay, velocity and acceleration analysis. Now let us start with some concept, okay, of circular motion. Okay, you might have done circular motion, but let us have a brief concept about circular motion, right? Suppose there is a particle, this particle, let me say this particle is particle P, right? And this particle P is having a circular motion, it is doing a circular motion. This kind of circular motion the particle P is doing. Okay, so if you consider the center, right, the particle P will be at different positions. Sometimes it will be here, sometimes it will be here, sometimes it will be here. So it is having a circular motion about the point O. It is having a circular motion about the point O. Now, if you consider the velocity of the particle, if it is moving in, say, anti-clockwise direction, right? So its velocity will always be perpendicular to the radius. The velocity will always be perpendicular to the radius. Or in other way, what I mean to say is the velocity is always, if you draw a perpendicular from the center, sorry, if you simply say, if you draw a line joining the point and the center, that line will be perpendicular to the velocity, right? This is a very simple concept. So what we can say, if you're drawing any line, or if you're joining the center of rotation, with the velocity, with the point which is having a circular motion, if you're joining the center of rotation with the point which is having a circular motion, right, the line that has been formed, OP in this case, will be perpendicular to the velocity, right? So that is a characteristic of circular motion, right? That is always hold true. Okay, that will always be hold true, right? So using this concept, we'll try to learn something about instantaneous center, right? We'll try to learn something about instantaneous center, right? Okay, so let us now consider any body. Which is having a general motion. So what exactly do I mean by general motion? It could be any kind of motion, right? It is moving somewhere. I don't know. Okay, not defined. Unless and until you give me the path, the locus of the motion, I cannot define what kind of motion it is. So I'm terming it as general motion, right? So I consider 3 points. I consider 3 points A, B, C, and I try to find out their velocities. I consider 3 points A, B, C, and I try to find out their velocities. Let me say the velocity of A. Velocity of A, point A is in this direction. Velocity of point B is in this direction. And velocity of point C is in this direction. In this motion, I randomly picked 3 points A, B, C. I randomly picked 3 points A, B, C, and then I tried to find its velocity. And I got to know these are the 3 directions of velocity. Now, next, what I do, this is something reverse engineering method. You can say this is a kind of a reverse engineering method. We're drawing perpendiculars to all these velocities. Let me say I draw perpendicular to velocity at point C. I draw perpendicular to velocity at point A, and I draw perpendicular to velocity of point B. So I draw 3 perpendiculars, as you can see, 3 perpendiculars. All the perpendiculars, they come and coincide at a point O. All the perpendiculars, they come and coincide at a point. So at this moment, at this moment, what does it feel like? It feels like, because all the points, you can see I have considered 3 points, all 3 points, the perpendiculars are intersecting at point O. So at this moment, it feels like the body. Which body we're talking about? We're talking about this body. The body is rotating. Rotating means it is having kind of a circular motion about point O. It feels like the body is rotating about point O, right? Or in the other sense, what is point O? Point O is the center of rotation. Point O is the center of rotation. Please let me make it very clear. This is at this moment. The next moment, the position of this body will change. The velocities, the directions of the velocities will change, because it's general motion. Actually, it is not having a rotating motion, right? It is not having a circular motion. This is a general motion, right? So the next moment, the position of this body will be completely different. It might be somewhere here. It might be somewhere here. The velocities might be directed in some different directions. I don't know, right? I cannot comment on the next moment, right? So at next moment, what will happen, I cannot comment. But at this moment, what I can say is, that this point O is the instantaneous center of rotation. As the name suggests, right? At this instant, this point O is the center of rotation. We also term it as I center. Right? Or sometimes we call it instantaneous center of rotation, ICOR. Right? So this concept we will use, right? We will use in velocity analysis of different mechanisms. We'll see how exactly we're going to use this method, this instantaneous center method, right? In this concept of instantaneous center in analyzing velocities. Okay. So how many eye centers can we have? Now, this eye center is for one body, right? This eye center we have predicted. This is a single body, right? This is a single body, na? This is a single body, one body. So one body, right? Now mechanism. One body means you can say one link. Take a link or body, right? But in a mechanism, how many links we can have? We can have n number of links. Suppose there is a link and there is one more link, right? So for these two links, is there any eye centers? Yes. For these two links also there can be eye center. What exactly is that eye center? If suppose this is the eye center for these two bodies. So about this eye center, it looks like at this instant both the bodies are rotating. Right, eye centers, there can, we will see how exactly to find out this eye center. This eye center we have spoken about. This eye center is very easy to find out. How? Simply draw perpendiculars. Sorry, simply find out the first, find out few velocities and draw perpendicular to the velocities. The point where the perpendicular to the velocities will meet, that is the eye center. This is for a single body, the eye center for a single body. Now if there are more than one body, suppose there are two bodies, right, they're linked, they're having some kind of relative motion to with each other, even then we can define this eye center. We are going to see how exactly we will find out the eye center. For it is a different method. It will not simply by drawing the perpendiculars. There is a different method. We have to understand, we have to learn that method. But let me first tell you that yes, there can be eye centers even for two bodies, right? So about this eye center, it looks like as if both the bodies at this instant are rotating. It looks like as if, because these bodies will have some relative motion to each other, because it's a part of a mechanism. There's a part of a mechanism. You consider any two links, right? If you consider any two links, the part of a mechanism, there will be a eye center. We'll see. What is the formula? How many total eye centers a mechanism can have? Suppose there are n number of links. Suppose number of links is equal to n, or let me say L. Number of eye centers can be given by n is equal to L into L minus 1 divided by 2. This formula is important. Sometimes directly questions are asked from this formula. This formula is important. Sometimes directly questions are asked from this formula. Okay. So let me say if L is equal to 10, what are the eye centers? How many number of eye centers will be there? N is equal to 10 into, और 10 बहुत ज़्यादा बड़ा हो जाएगा. Let me say 5. Let me say 5. 10 will be a very big number. 5. So n is equal to 5 into 5 minus 1 divided by 2. N is equal to 5 into 5 minus 1 divided by 2 is equal to, you can see this will be equal to 10. At 5 into 2, that is equal to 10. So there are 10 eye centers. Let me try to find out what are those eye centers, right? It will be eye center 1. So let me say the links are 1, 2, 3, 4, 5. These are the 5 links. These are the 5 links. So what are the eye centers? I12, I13, I14, I15, I23, I24, I25, I34, I35, I45. So let us count how many eye centers in total. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 eye centers if the number of links are 5. Okay. So please remember this formula. This formula is important. Objectives are directly asked. Okay, so let us try to find out basic eye centers in a mechanism. Basic eye centers means, suppose there are two links. If you consider any two links, so what will be the eye centers? First, let me start with a turning pair. Let me start with a turning pair. Turning pair. Turning pair. If I say a turning pair, all of us know about a turning pair. This is a link, and this is another link. Both of them are joined here. So link 1, link 1, link 2. The eye center is at the intersection point I1. It's a very simple way. If you sit at the joint, hinge joint, you will definitely feel both the links are rotating about hinge joint, right? Both the links 1 and 2 are rotating about the hinge joint, right? So for the turning pair, it is very easy to find out a eye center. For a turning pair, it is very easy to find out a eye center. What about a rolling pair? Let me consider a rolling pair. To rolling pair. If I say rolling pair, suppose there is a sphere, or let me say cylinder, whatever, sphere or cylinder, rolling on ground. So where will be the eye center? Where will be the eye center? Let me say the fixed length is 1 and the rolling member is 2. The eye center will be at the connecting point. I. Okay. Okay. So these are some of the very few simple objective questions that are being asked. What is the eye center of a rolling pair, a sphere rolling and a sphere, right? So this is basically the point of contact. Point of contact. Point of contact. What about a sliding pair? Let me see. Let us see the eye center of a sliding pair. Let us see the eye centers of a sliding pair. Let us see the eye centers of a sliding pair. So if you see the eye centers of a sliding pair, right, how to predict? First, let us draw the ground on which the member is sliding. Let me say this is 1. And on this ground, there is a member, let me say a rectangular block. This is sliding. Okay, this rectangular block is sliding on ground. So what we are going to do, the very simple way, since this is very simple way, we'll find out the velocity. Let me say this is point A, this is point B, right? This is velocity of point A, this is point B, this is velocity of point B. What we are going to do, we'll draw two perpendiculars. We'll draw two perpendiculars to the velocities. We'll draw two perpendicular to these velocities, right? So the point where this perpendicular meet is the eye center. The point where the perpendiculars meet is the eye center. So where exactly this two perpendiculars meet, can you tell me? It is meeting at infinite, right? Infinity, right? It is meeting at infinity. So for a sliding pair which is sliding on a straight surface, right? The eye center is at infinity. Please remember this. Again, important objective being asked. Now, sliding can also happen in curved surface. For example, this concave, draw it a little bit smaller, concave or convex, right? So if the sliding is happening on concave surface, right? If you try to find out the eye center, just draw the velocities and directly citing it to you. The eye center is at the center. If it is sliding on a convex surface, right, the eye center will be at the center again, right? For sliding on curved surface, for sliding on curved surface, eye center is at the center of the curve. Is at the center of the curve. So these are the few eye centers that you will have to remember, right? Very easy actually, right? The most frequent are the first three, you can say. The turning pair, definitely you should know, very simple to remember. It is at the common point. Rolling pair, it is a point of contact. Then sliding pair on a straight surface, right? On a straight surface, the eye center is meeting at the infinite, right? And this way you also had the basic understanding how to find out the eye centers. This way you also had the basic understanding of how exactly to find out the eye centers. Now let us consider a 4-bar mechanism. Let us try to find out the eye centers of a 4-bar mechanism, right? 4-bar mechanism. छोटा बनाते हैं so that ठीक है हो जाएगा. So all of you now know what is a 4-bar mechanism. All of you now know what is a 4-bar mechanism, right? All of you now know what is a 4-bar mechanism. Now let me say this is a 4-bar mechanism. This is link 1, this is link 2, this is link 3, and this is link 4, right? Basically this is a kinematic chain. Only once you fix one of the surface, it will be a 4-bar mechanism. Only once you fix it, it will become a 4-bar mechanism, right? So let us first find out how many eye centers will be there. N is equal to 4 into 4 minus 1 divided by 2, that is equal to 3 to the 6 eye centers. There are 6 eye centers. What are the eye centers? I12, I13, I14, I23, I24, I34. So these are the 6 eye centers for the 4-bar mechanism. So if I'm saying I23, what exactly 23 means? I23 is the point about which both link 2 and link 3 seems to be rotating. Similarly, what is I24? The point about which both link 2 and link 4 seems to be rotating at this instant. Definitely it can change, okay? But at this instant. Okay. Okay. So there is a proper method to determine the eye centers. There is a proper method to determine the eye centers. Okay. So let us first see which of the eye centers we already know. Okay. Which of the eye centers we already know? We know these are all turning pairs. Okay. We know eye center I12. This is I12. We know this. We know this is eye center 2, 3, right? Because this is the intersection point of 2 and 3, right? Intersection point of the link 2 and link 3. I've already seen, right? These are turning pairs. I23 also we know. This is I34. We know it. And this is I14. We know it. So this we already know. Which eye center we need to find out now? We need to find out I13 and I24. These are the 2 eye centers we need to find out. These are the 2 eye centers that we need to find out. I13 and I24. Let us try to find out these eye centers. Okay. So for that, what we are going to do is we will draw a circle diagram. Which diagram we are going to draw? We are going to draw a circle diagram. Okay, this is a very easy diagram. This is a very easy diagram. Okay. Just hold on. How exactly to draw a circle diagram? Now, let us first draw a circle. Let us first draw a circle. Now let us mark all the links on this circle. What are the links? What are the links? What links are there in the circle? What links are there? There is link number 1, link number 2, link number 3, and link number 4. Let us mark all the links. 1, 2, 3, 4. Then we will join all the links that are marked. Will join all the marked links for which I center is known. Now, which I centers we know we are going to join the links. We know I center 1 and 2, so we're going to join link 1 and 2. We know I center 2 and 3, 2, 3, so we're going to join 2 and 3. We know I center 3, 4, right? So we're joining 3 and 4. We know I center 1, 4, so we are joining 1 and 4. Okay? Now we are left with two I centers. That is, we have already seen in last which I centers we need to find out: 1, 3 and 2, 4. We need to find I center 1, 3 and I center 2, 4. Right? So let us try to find out how to find out the I centers 1, 3 and 2, 4. Let us try to find out how to find out I centers 1, 3 and 2, 4. तो बहुत सिंपल है. If you want to find out I center 1, 3, if you want to find out I center 1, 3, what you have to do, you have to find two path to reach from point 1 to point 3. So this is point 1, this is point 1, you need to reach 3. You need to find two known paths to reach I center from point 1 to point 3. So how to do it? What are the two paths? I can say one path is, I can say that the one path is this one. I go from 1 to 2, then 2 to 3, means I1 2, I2 3. Then what is the second part? The second part is I can go from 1 to 4, then 4 to 3. I can go from 1 to 4, then 4 to 3. I1 4, I4 3. I1 4, I4 3. Okay. Similarly, if you want to find I24, if you want to find I24, I24, you need to find out two paths. You need to find out two paths, right? What are the two paths? Let me say I want to go from 2 to 4. 2 to 4. So 2 to 4, I can go from 2 to 3, then 3 to 4. I2 3, I3 4. Then I can go from 2 to 1, right? And then 1 to 4. So I 2 1 or 1 to are same. I1 2, I1 4. Okay, this much you have to do first. Right? This much you have to do first. After that, we'll see. Once you have done this, now simply join the lines. Okay, now simply join the lines. I1 2 2 3, 1 2 2 3. I1 2 2 3. This is 1 2 2 3. Let me join this line. Sorry. I don't know why it is happening this way. Okay, fine, whatever. 1 2 2 3. 1 2 2 3. Then 1 4 4 3. 1 4 4 3. Okay, the point where this intersects, the point where it intersects, right, is nothing else but eye center. The point where it intersects is nothing else but the eye center. Eye center I 1 3. Eye center 1 3. Similarly, if you want to find out eye center 2 4, what you have to do, you have to join 2 3 3 4. 2 3 3 4. This is the line joining 2 3 3 4. We'll extend this one. Okay, then 1 2 1 4. It will come and intersect somewhere here. So this is the eye center I. Sorry, the weather is little bit cold. It is raining from morning, so I think I have got a little bit of cold. Might be okay. So I hope you got to understand how to find out the eye centers of a 4-bar mechanism. So this same procedure you can extend if even if there are 4 links, 5 links, 6 links, 7 links, 8 links, right? Whatever kind of links it might be a turning pair, it might be a uh, rolling pair, it might be a sliding pair, right? Generally, two common pairs that are noticed in mechanisms are sliding pair and turning pair. Sliding pair, like in single slider crank mechanism, double slider crank mechanism, right? Even in single simple mechanisms, you could have found these sliding pairs. Okay. Okay. Can you hear me now? Am I audible? Okay, fantastic. Right. So this is the method to find out the eye centers. So why exactly we are finding out the eye centers? Why exactly we are finding out the eye centers? So in this chapter, velocity and acceleration analysis, what we do actually, in the first chapter, we try to understand the mechanisms that will be converted, that will be used in machines, right? Machines are structures, but if you see, if you just try to draw the skeleton of the machines, right, it will be some or the other mechanism. Simply draw the If you simply draw the skeleton of the mechanism used, right, it is simply either the one of the mechanisms, right? Now you have to understand, you have to find out, if you know the velocity of the input, that will be something which is known, right? Velocity of the input, you should be able to find out the velocity of the output, right? That is what we try to learn in this chapter. In velocity analysis, we try to find out the relationship between velocities of different links of a mechanism. If we know the velocity of one link, sorry, if we know the velocity of one link, we should be able to find out the velocity of any other link in that mechanism. Okay. Okay. Now let us see a theorem which is known as Kennedy's theorem. A one-mark question can be asked. Okay, what is Kennedy's theorem? For relative motion between the number of links in a mechanism, for any three links, if you choose any three links, their eye centers would always lie in a straight line. Right? If you see this, if you choose any this motion, this mechanism can have relative motion. The different links, definitely 2, 3, 4, they will have relative motion among each other. So if you choose any three links, their eye centers will be in a straight line. For example, if you choose link number 2 and 4, Sorry. How come suddenly is this in a matter of half an hour? Anyways, okay, fine. We'll try to finish it off. So if you consider link number 2 and 4, what are the associated uh, eye centers, right? Any three links. Take it. Okay, we choose link number 1, 2, and 4. 1, 2, and 4. What are the associated eye centers? I12, I14, and I24. Let us try to find out. Let us try to plot these eye centers. I12, this is I12, this is I12, right? I14, this is I14, right? This is I24, this is I24. You can see all three are in the same straight line. All three are in the same straight line, right? So you just need to remember what is Kennedy's theorem. So this Kennedy's theorem is the basis of angular velocity ratio theorem. Angular velocity ratio theorem. So that is the basis, right? What exactly is the angular velocity ratio theorem, right? Let us try to see. Using Kennedy's theorem, we can derive the relationship between the fixed link 1, link M, and link N. Let us consider this. For example, let me say this. Let me consider this mechanism. Okay. Suppose link 1 is the input link. Let me say link 1 is the input link and link 4 is the output link. Right. So you know the velocity of the input link. It is given. Omega 2 is given in equation. Given. So you need to find out omega 4. Right. You need to find out the velocity of the output link. So in that case, what you can do is you can actually use the angular velocity theorem, right? So what are the three links that you have to use? Definitely link 2 and link 3 will definitely be in picture, and the third link that will be in picture is the fixed link. So all these three links will be in picture while writing down the angular velocity theorem. Link 1, link 2, and link 4, right? So how can I write down the angular velocity theorem? Very simple. Omega 2 is given, and I need to find out omega 4, right? I need to find out omega 4. So omega 2 multiplied by I12, I24, right? Is equal to omega 4 multiplied by I14, I24. So you have these three links. These three links. There will be three associated eye centers. What are the three associated eye centers? I12, I14, I24. These are the three associated link eye centers with respect to link 1, 2, and 4. So omega 2 multiplied by this distance. This distance. We have already found out. Have you found out I24? What was I24? Where did you find out I24? You can see it here. This is I24. This is I24. Let us draw it. We have already found out I24. Let us draw it. This is I24. Right? So basically, what is this considering? This is the length I1224. Length 1224. This is the length 1224. I12, I24. And this is the length I1424. I1424. This is the length. This is the length I1424. This is the length I14, I24. It's the length I14, I24. Is it okay? Did you understand the angular velocity theorem? Is something you remember, right? Questions might be asked from this theorem. We'll see. We'll try to solve problem. We'll try to solve problem. So after solving problem, you'll have better understanding. After solving problems, you'll have better understanding. Is it okay now? Okay, good. Now, one more point to be noted here. One more point to be noted here. Now, angular velocity is a vector quantity. This is a vector quantity, right? What is angular velocity? Is a vector quantity. What is angular velocity? Angular velocity is a vector quantity. Okay, so vector quantity means magnitude as well as direction. So this theorem, this is going to give you the magnitude. This is going to give you the magnitude. So how to find out the direct? How to find out the? How to find out the direction? You have to use a simple concept. You have to use a simple concept. If I 1m and 1n means in this case I 1 2 and I 1 4, they're in the same side of I mn. This would be mn actually. Same side of I mn means 2 4, right? Then direction of angular velocity will be same direction. If I 1 2 and I 1 4 are in opposite side of I 2 4, then the direction will be opposite, right? For example, if you see here, this is I 2 4. If you see here, this is I 2 4, right? This is I 2 4. This is I 2 4, right? If you see both 1 2 and 1 4 are in the same side of 2 4. 1 2 and 1 4 both are in the same side of 2 4. In that case, the angular velocity, in that case, the direction of angular velocity omega 2 and omega 4 will be same. In that case, the direction of angular velocity omega 2 and omega 4 will be same, right? If omega 2 is clockwise, omega 4 will be also be clockwise. If omega 2 is anti-clockwise, omega 4 will also be anti-clockwise. But in case if 1 2 and 1 4 are on the either side of 2 4, for example, इसी में दिखा देता हूँ, just have an imaginary case. Let me say this is an imaginary case, right? Let me say this is I24. Let me say this is I24. Let me say, okay, this is not the case. I24, this is, let me say 1 2 and this is I14. Suppose ऐसा हो गया, ठीक है? In that case, you can say, see, I12 and 14 are opposite side of 24. That is, the direction of the two angular velocities omega 2 and omega 4 will be opposite. Means if omega 2 is clockwise, omega 4 will be anti-clockwise. Okay? Okay. Try to solve this question. At least find the icenters. What is given? Very easy. Very easy actually. Directly you can find it out. Right? Omega O2A is given, omega is given of O2A. You need to find out the angular velocity of O. The same exactly what you have discussed. Exactly what you have discussed. देखिए एक बार. Try to find it out. Take a So could you find out which? Just hold on. I'll just take a medicine so that problem is at least delayed. Okay. So let me mark the links. One, two, sorry. One will always be the fixed link. Always remember, we'll mark the link, the fixed link as one. This is link two, this is link three, and this is link four. So what exactly is given to us is O2A means omega 2 is given as 8 radian per second. And what you need to find out is magnitude of angular velocity of O4B. O4B, this is O4. O4B means omega 4 is what you have to find out. Very simple, right? So we have to find out I24. We have already seen how to find out I24, right? We have already seen how to find out I24. Okay, this will be nothing else but I24. I24. This is I24, right? So we know the angular velocity theorem also. Let us write it down. According to angular velocity theorem, omega 2 into I12 I24 is equal to omega 4 into I14 I24. So what is omega 4 now? Omega 4 is equal to omega 2 multiplied by I12 I24 divided by I14 I24. Right? What is 1224? This is 1224. We all know. Let us let us try to mark the other eye centers also. That will help us. Okay, let us try to mark the other eye centers also. So this is I12. This is I24. This is I23. This is I34. We have already seen this, right? We have already seen this, right? So what is I1224? This is I1224. This distance is I1224. This distance you can see is I1224. And which distance is I1424? This distance is I1424. Can we find out the ratio? Can we find out the ratio? Can we say triangle? Let me say this is O2, this A, B, then this is O4, right? Let me say this is X. Can I say the triangle AXO2? Can I say triangle AXO2 is similar to, right? Is similar to triangle A, or say, let me say BXO4. Yes or no? Two angles are equal. All the angles are equal, right? A, this angle is equal, this angle is equal, this angle is equal, right? This angle is equal to this angle, 90 degree, 90 degree. This is the common angle, right? A. So in that case, can I say I12 I24 divided by I14 I24 is equal to O2A divided by O4B? Yes or no? That is equal to O2A is given as 60, O4B is given as 160. Can I say omega 4 is now is equal to omega 2 is 8 into 60 divided by 160? This is 20. So this is equal to 3. Right? So what is the value of omega 4 now? Omega 4 is equal to 3 radian per second. Omega 4 is equal to 3 radian per second. Right? So is it clear? थोड़ा सा lengthy है. This question is good with respect to gate, not with respect to HL. But yes, if you can understand this, then I don't think you should have any problem in other questions also. Okay, so this is our eye center method. This was our eye center method. Okay, this was the eye center method. So this way, even if there are n links, suppose there are n number of links, suppose there are 5, 6, 7, 8, 9, 10 links, whatever. Okay, you can easily find out if you have the velocity of link number 2, you can also find out the velocity of link number 3. How? Using the eye center method. For that, you have to first plot all the eye centers. First, you have to plot all these eye centers. So once you have plotted all the eye centers, it becomes very easy for you. It becomes very easy for you. If you know the velocity of first link, you can easily plot the velocity of the any other links in that mechanism, right? So this is how we find out the velocities, right? So what is our motive exactly? Motive is first we have learned the mechanisms, then we are trying to find out the velocities, then rate of change of velocities will become acceleration, and then acceleration multiplied by the mass will become force. So we'll be able to find out how much force, if we apply on the input link, how much force will be generated in the output link. So this is our general motive. What I'm trying to say is this is our general motive. Okay, so that was our first way of solving velocity problems. The second way of solving velocity problems is relative velocity approach. The second way of solving velocity problem is relative velocity approach. So what is relative velocity approach? Relative velocity approach, right? We'll try to understand. Okay, we'll try to understand. Okay, we'll try to understand. Okay. Now, if you consider any link, if you consider any rigid link OA, right? Be it rotating about any point or whatever, right? Okay, let me for the sake, let me consider a link OA which is rotating about point 2. Let me say this is a link OA which is rotating about point 2. This is link, this point is O, this point is A, and this link OA is having some angular velocity, is rotating about point O with some angular velocity omega. With some angular velocity omega. Right? Now, first of all, what you have to understand here is, first of all, you have to understand here is, if you consider the velocity of any point in OA with respect to point O, if you consider velocity of any point in the link OA with respect to point O, it will always be perpendicular to the link OA. For example, let me say this is a point X. If you try to find out the velocity of point X, because the whole link, it is a rigid link and the whole link is rotating about point O, velocity of point X will be in this direction, v of X, and it will be perpendicular to the link OA. You take any other point Y, the velocity of point Y will be in this direction and it will be perpendicular to that link. Right? So this very concept is used in the relative velocity approach. This concept will be used in relative velocity approach. So if you sit down at one point, what you are going to see is that the velocity of the other point will be perpendicular to the line joining the 2 points. Right? Velocity, simple word, if I say simple word, I'll say that velocity is perpendicular to the line joining राइट। और थोड़ा सा प्रिसाइज कर दे तो ऐसे बोल सकता है, इफ द वेलोसिटी ऑफ एनी पॉइंट is seen relative any other point in a rigid link in a rigid link, if the velocity of any point is seen relative to any other point in a rigid link, the velocity will be perpendicular to the line joining the 2 points. Right? For example, if you're sitting at point O, if you're looking from point O, if you're trying to look at the velocity of point X, right, the velocity will be perpendicular to OX. If you're sitting at point O and trying to look at the velocity of point Y, the velocity will be perpendicular to the line OY. Right? Even if you want to find out the velocity of point A, what will be the direction of the velocity of point A? It will be perpendicular to the line OA. Right? So this concept is used for the relative velocity approach. So let us do the same problem. Let us do the same problem that we have learned earlier, done earlier with the eye center method, with the relative velocity method this time. Okay? Ready to go? Ready to go? Okay. The first step will be to the first step will be step 1, or let me write this step 1 here, step by step. What will be the step 1? Step 1 will be to plot the fixed points, all the fixed points as a single point. To plot all the fixed points as a single point. So what do I mean by plot all these fixed point as a single point? It means that, right, how many fixed points are there here? O2 is a fixed point, O4 is a fixed point. So what we will do, we'll plot O2 comma O4 as one single point, because all are fixed na, they don't have any relative motion with each other, right? So all will coincide, because what we are trying to draw is a velocity diagram here. What exactly we are trying to draw here is a velocity diagram. Velocity diagram. What exactly we are trying to do is draw a velocity diagram. What exactly we are trying to do here is draw a velocity diagram here. Okay, so the first step is to mark all the fixed points. So in a mechanism, there can be more than two fixed points, in fact, right? This is a four-bar mechanism, so you're seeing only two fixed points, O2 and O4. There might be more than there are 3, 4, 5, 6, 7 fixed points. All the fixed points will be marked as one, right? Okay, then serially we'll proceed. Okay, from O2 we'll plot the velocity of point A, then from A we'll plot the velocity of point B, then from B we'll plot the velocity of point other points. Okay, okay. So step 2 will be, what will be step 2? Plot velocity of point A. Plot velocity of point A. So if you want to plot velocity of point A, can I say the velocity of point A will be a line perpendicular to OA? Yes or no? Velocity of point A will be line perpendicular to OA. So definitely the velocity of point A will be line perpendicular to OA along this line. Velocity of OA will definitely be along this line. Do we know the magnitude and direction? Yes, we know the magnitude and directions also. You can see if omega is in this direction, it is given omega is in this direction, definitely VA will be somewhere in this direction. Do we know the velocity VA? Can we find out? Yes. Why? Because omega is given. VA is equal to omega of link 2 multiplied by O2A, that is R, right? Omega R, that is equal to 8 into 60 mm. It is given as 60 mm, so 0 0.6, 0 0.06 meter, that is equal to coming out to be 0.48 meter per second. Right? It is coming out to be 0.48 meter per second. Right? Let me plot it somewhere here. Let me say the velocity of point A is somewhere here. This is point A. Right? And this is what? This is velocity of point A. Right? This is what? This is VA. Okay? So all the conditions are fulfilled. Perpendicular to line OA, you can see this velocity is perpendicular to line OA. Direction is in the direction of omega, right? And the magnitude is also here plotted, right? This distance, this is basically graphical method. This is basically graphical method 0.48. This distance is 0.48. Okay, nice. So with respect to A, now if you sit down at point A, if you sit down at point A and you try to find out the velocity of point B, if you sit down at point A and you try to find out the velocity of point B, can we say the velocity of point B will be perpendicular to the line OA? Velocity of point B will be perpendicular to the line AB, sorry. Can you say the velocity of point B with respect to A? Velocity of point B with respect to A will be perpendicular to line AB? अभी अभी देखा है ना ये चीज, right? If you sit down at a point and look at the other point, its velocity will be perpendicular to that line. So if you sit down at point A, if you sit down at point A and try to look at the velocity of point B, right? It will be definitely along this line. This. Now we don't know the direction. It could be downwards. It could be upwards. We don't know that direction, but definitely we can say that the velocity will be perpendicular to the line AB. Definitely, what we can say is that the velocity will be perpendicular to the line AB. Right? इसको थोड़ा सा shift कर देते हैं so that we are able to draw it properly. Shift it a little bit. Okay. So we'll draw a line perpendicular to AB, passing through point A. Draw a line perpendicular to AB, passing through point A. We don't know. It could be the velocity could be on the top or it could be on the bottom. We don't know that. Okay. Now, ठीक है, simple है, ठीक, I know with just one problem it is difficult. It is difficult to grasp the whole concept with a small one problem, right? But देखते हैं, whatever is possible in 2 hours we'll try to learn. ठीक है, because the questions won't be of this magnitude. The questions will be very simple. If you have done one numerical, you have understood one numerical, right? So what will happen, the simple one liner questions, conceptual questions, you'll be able to understand, you'll be able to answer, right? This is the main motive, right? Now, if you sit at point 0.04, now if you sit at point 0.04 and you try to see the velocity of point B, what will be the direction of velocity of point B? Can I say, I don't know in which direction, but definitely I can say the velocity of point B with respect to 0.04 will be perpendicular to 0.4B. I don't know would it be in the right or would it be in the left, but definitely I know that it will be perpendicular to the line O4B. So I simply draw a line perpendicular to O4B. So I simply draw a line perpendicular to O4, passing through O4. Right? So simply draw a line O4 perpendicular to the O4. Same na. With respect to O4, we are saying it with respect to O4. So definitely with respect to O4, right? The velocity will be a line perpendicular to O4B. So with respect to O4, a line passing through O4 and perpendicular to the line O4B. So this is the third line. Now let us review once again. With respect to A, we are saying the velocity of point B is in the green line, and with respect to O4, I'm saying the velocity of B is in the along the yellow line. So it is only possible if the velocity of point B is at the intersection of the two lines. It is only possible because I am saying with respect to A, the velocity of point B should be in the green line, perpendicular to line AB. I don't know, it could be up, it could be down, I don't know that, but at least I know that it should be velocity of point B should be in the green line, right? Now, similarly, with respect to O4, I can again say I don't know in towards right or towards left, but definitely the velocity of point B should be along the line, along the yellow line. Now, both the points can be satisfied only if the velocity of point B lies at the intersection of the two lines. So, from here you can see the point A and B are coinciding. Here you can see the point A and B are coinciding. What does that mean? That velocity AB is equal to 0. Velocity of A with respect to B or velocity of B with respect to A is equal to 0 because the distance AB is 0. Distance AB is 0, right? But velocity of point B is equal to velocity of point A is equal to 0.48 meter per second. This is also something we can comment because this is nothing else but velocity of point B also. This line is velocity of point B. This line is also velocity of point A. O2A. What is O2A? O2A is VA and O4B is VB, and both of them are similar. So I can say VB is equal to VBA is equal to 0.48, right? So can I find out omega B now? What is omega B? Or let me say not omega B. Okay, better to say omega 4. Can I say omega 4 is equal to VB divided by O4B? This is 4 na, link 4 na. This is link 4 na, right? So what is the omega of link 4? Omega 4, right? Omega, what is the velocity? Velocity is VB, right? Velocity is VB, right? So if I say VB is equal to omega 4 into O4B, or I can say omega 4 is equal to VB into O4B, so this is equal to 0.48 divided by 160. If you want it in radian, right? If you want it in radian, because this 160, it will not be 160, 0.16. So how much it is coming out to be? Omega 4 is coming out to be 3 radian per second. What is the magnitude of omega 4? Omega 4 is 3 radian per second. So did you get the same answer in our eye center method? Yes. We found out omega 4 is equal to 3 radian per second. Even in this method, we have found out that omega 4 is equal to 3 radian per second. Okay, is it clear to some extent? Okay. Just hold on. Okay, he got disconnected, it seems. Anyways, let me wait. He'll get connected and we can start. Okay, right? So what is the step 3? So we have plot velocity of point A, and step 3 is, what is step 3? Step 3 is plot velocity of B with respect to A. So what is step 4? Plot velocity of B with respect to O4, right? Then your diagram is complete, right? After that, we can easily find out the respective velocities. After that, you can easily find out the respective velocities, right? Okay, so this was your relative velocity concept. I know it might be a little bit tough. I know it might be a little bit tough, but okay, understand the basics at least. You will be able to understand, you'll be able to answer at least few questions, right? The questions that are at least asked in HL, they will be of easy nature, so you need not worry much. You need not worry much. The questions that will be asked will be of easy in nature. It will not be of this level, right? But we are trying to do it at a level which is at least above the HL exam, so that when you face the actual exam, right, the HL exam, you will find the questions to be a bit easy. Okay, you'll find the questions to be a bit easy. Okay, now let us consider one more question. A rigid rod of length 1 meter, a rigid rod of length 1 meter, which is at an angle of 45 degree. So this angle is 45. Definitely this angle is also 45. The NP is dragged with a velocity of 5 meter per second towards right. So the P, side P, is dragged with a velocity of 5 meter per second towards right. You can see the velocity of point P is u is equal to 5 meter per second, right? At this instant, the velocity of NQ is. So what is being asked? What is the velocity of NQ? What is the velocity of point Q, right? So there are many methods. We'll try to do it the eye center method. We'll try approach of eye center method, right? So what is the eye center method? First, we'll have to plot the eye center of the point PQ, right? We know that velocity of point P, we definitely know that velocity of point P is in this direction. Velocity of point Q is in this direction. So if you want to find out the eye center, how exactly to find out the eye center? Simply draw a perpendicular to link the velocity of point Q. Draw a perpendicular to the velocity of point P, right? So the point where this lines will meet will be nothing else but the eye center of the link PQ. This will be eye center of the link PQ. Just hold on. Okay. Sorry. Just I'll share the screen once again. Okay, so this is the eye center PQ. This is the eye center PQ. This is the eye center PQ, right? So can you find out the angular velocity of the link now PQ? Can I say the angular velocity of the, because at this instant it seems like the member PQ is rotating about the eye center. Can I say the angular velocity of the link PQ is equal to the velocity of point P divided by the eye center, IPQ P? This distance, this distance is nothing else but R now, right? This distance is nothing else but R, right? So what is VP now? VP is equal to 5. We know that this VP is equal to 5. It is given in the equation, right? That is equal to U, right? Divided by this distance. Now what will be this distance? This angle is 45 degree. So can I say this is 1 cos 45 or simply cos 45 degree? This is nothing else but cos 45 degree, right? This is omega PQ. Now if you know omega PQ, can you find out the velocity of point PQ? Velocity of point Q is equal to, can I say omega PQ multiplied by I PQ into Q, that is equal to 5 divided by cos of 45 degree multiplied by, what will be this distance? Can I say this distance is also is equal to 1 cos 45? So cos 45 will cancel out. So what is velocity of point Q? Velocity of point Q is also 5 meter per second. Velocity of point Q is also 5 meter per second. So this way you were able to find out there are three questions in this one question. First of all, what is the eye center? You might be asked what is the eye center, right? Second, what is the angular velocity? You found out what is the angular velocity. Third, you found out the velocity of point Q. Third, you found out the velocity of point Q, right? So there are three different questions inside the one question. Okay, let us now try to understand the concept of radial and tangential acceleration. So this is all for your relative velocity concept. Okay, so we have done two methods. One is the eye center method, and the second one is the relative velocity method. Okay, so after that, now we are progressing into, after that what exactly we are doing, we are progressing into the, now we are progressing into acceleration part. Now we are progressing into acceleration part. So let us have a very brief idea about radial and tangential acceleration. Radial and tangential acceleration, right? This is something important, right? This is something important. Simple questions are asked from this concept also. Okay, so we'll not go into very depth. It is not possible, simply not possible to get into very much depth of this concept. But whatever is feasible, we'll go through definitely. So let me consider this link. Let me consider this link, right? Let me say this is OA, link OA, right? And the link OA is having a angular velocity of omega and an angular acceleration of alpha. Let me say the link OA is having an angular velocity of omega and an angular acceleration of alpha. Okay, so now if you see, if you take any point, let me say consider any point, you can consider any point. Let me say, let us consider point A. So what will be the direction of velocity of point A? This is the direction of velocity of point A, VA. Right? This is the direction of velocity of point A, VA. Now, if you consider about acceleration, there will be two types of acceleration. If you consider about acceleration, there will be two types of acceleration. One will be the radial acceleration and the other is the tangential acceleration. One will be radial acceleration and other one is the tangential acceleration. So if you consider the radial acceleration, radial acceleration will always be directed towards center. Directed towards center. You might have studied this in your circular motion chapter in engineering mechanics, And what is the magnitude of radial acceleration? Radial acceleration is omega square r. What is the magnitude of radial acceleration? It is omega square r. Right? And their tangential acceleration component, the tangential acceleration component, it is always perpendicular to link OA. To link. Perpendicular to link OA. And what is the magnitude of the tangential acceleration? It is equal to alpha into r. What is the magnitude of tangential acceleration? It is alpha into r. So these 2 points you'll have to remember. These 2 points you'll have to remember. You'll have to remember these 2 points. What is the magnitude of radial acceleration and what is the magnitude of tangential acceleration? Okay. So if you want to see the direction, let us go through the direction, see the direction. So what is the direction of radial acceleration? This is the direction of radial acceleration. This is the direction of radial acceleration, AR, and this is the direction of tangential acceleration, AT. So tangential acceleration has the same direction as that of alpha. If alpha is in this direction, tangential acceleration in this direction. If alpha is in opposite direction, let me say the value of alpha is in opposite direction. In place of this, if I say the value of tangential alpha, if the value of alpha is in this direction, what will be the direction of tangential acceleration? Tangential acceleration will be this direction, right? So in this case, the velocity is decreasing, va is decreasing with time. In this case, va velocity is increasing. It is the case of acceleration, this is case of retardation. Okay. Okay. So now there is a third kind of acceleration which is also known as Coriolis acceleration. There is a third kind of acceleration which is known as Coriolis acceleration. Right? We'll try to find out what is a Coriolis acceleration. What exactly is Coriolis acceleration? So the Coriolis acceleration, right, is experienced by a member, right? It is experienced by a member which is sliding on a rotating link. Coriolis acceleration is experienced by a member which is sliding on a rotating link. Coriolis acceleration is experienced by a member which is sliding on a rotating link. Which is sliding on a rotating link. For example, यहाँ पर हमने एक example लिया है. We have taken an example here, right? So this is a slider, you can see, and this is a link which is a rotating link. This is a rotating link. So the slider is sliding in the rotating link. So the slider is going to experience some Coriolis acceleration. The slider is going to experience some Coriolis acceleration, right? So let again, the Coriolis acceleration will have magnitude and direction. So what is the magnitude of Coriolis acceleration? It is given by 2 into v into omega, where v is equal to velocity of sliding velocity, and omega is the angular velocity of link, angular velocity of the rotating link, where omega is the angular velocity of the rotating link. Okay, so what are the different steps? Let us go through the different steps now. Let us go through different steps to find out the direction of Coriolis acceleration. So this, the magnitude of Coriolis acceleration, you can very easily find out. It's a very simple formula, 2 into v into omega. So let us try to find out the direction of Coriolis acceleration. So what is the direction? How is the direction of Coriolis acceleration is given, right? First, first we will take the sense of angular velocity of the link, like clockwise or anti-clockwise. There can be two sense of the angular velocity of the link. It could be clockwise or it could be anti-clockwise. Then we will rotate the velocity vector of the slider by 90 degree in the sense of angular velocity. For example, if the angular velocity is clockwise, we'll rotate the direction of velocity of slider by 90 degree clockwise, or vice versa. Now, new direction obtained, the direction obtained is the direction of Coriolis acceleration. The direction obtained is the direction of Coriolis acceleration. So let us take this example. Let us take the example. Let us try to find out the direction of Coriolis acceleration here. Let us try to find out the direction of Coriolis acceleration here. Right? So in which direction is the angular is the link rotating? Can I say the link is rotating in counterclockwise direction or anti-clockwise direction? So what I'm going to do, I'm rotate the velocity vector of the slider. This is the velocity vector of the slider by 90 degree anti-clockwise. If I say 90 degree anti-clockwise, so this will be the direction of Coriolis acceleration. So this will be the direction of Coriolis acceleration. I've rotated the I've rotated the velocity vector by 90 degree anti-clockwise. Okay. Now in this question, what is the question given here? For the slider sliding in the link at a distance of 2 meters from the pin joint as shown in the figure, find the resultant acceleration of the slider. So your velocity of the slider given, angular velocity is given, and angular acceleration is given. So there will be three types of acceleration in this member. There will be a radial acceleration. There will be radial acceleration AR. There will be Coriolis acceleration, and also there will be a tangential acceleration AT. There will be a tangential acceleration AT. Right? So what is the value of AC? Now let us calculate what is the value of AC here. Coriolis acceleration is 2 into V into omega. So 2 into V is 2 into omega. Omega is 3. So this is 3 to the 6. 6 to the 12 meter per second square. What is the magnitude of tangential acceleration AT? Tangential acceleration can be given by alpha into r. Alpha is 1 radian per second square and r is 2 meter, already given in the equation. So this is equal to 2 meter per second square. Similarly, what is the value of radial acceleration? Radial acceleration can be given by AR. AR is equal to omega square r. Omega is 3 square into r is 2, 9 to the 18 meter per second square. So what is the total acceleration? Now can I say now acceleration perpendicular to the slider? Total acceleration, I can say it is equal to AC plus AT whole square plus AR whole square, right? Because AC and AT are in the same direction, they will add up, and AR is perpendicular to that resultant, right? So the angle between these two is 90 degrees. So you can directly say it is root over AC plus AT whole square plus AR square. So the total acceleration A is equal to, the total acceleration A is equal to AC is 12 plus 80 is equal to 2, 12 plus 2 whole square plus 18 whole square root over. So what is the answer? Let us check. 12 plus 2 is 14 whole square plus 18 whole square. That is equal to 520. Root over answer is 22.8. What is the total acceleration of this member? It is equal to 22.8 radian per second. It is 22.8 radian per second. I hope it is clear to all of you. I hope it is clear to all of you. I hope it is clear to all of you. So this is all about today's chapter. This is all about today's chapter. Thank you. Right. So we have done considerable amount of things in a very short period of time. Right. We have seen the instantaneous method. Right. How to find out eye centers. Then you have to see how the instantaneous method to find out velocities of different links. Then you have seen the relative velocity method. Then you have little bit of idea about acceleration, three types of acceleration, that is tangential acceleration, radial acceleration, and your Coriolis acceleration, right? And we have done a very wonderful problem, right, from this concept. Okay, that's all for today. That's all for velocity and acceleration analysis, right? Thank you all of you. So we'll meet again tomorrow with new chapter, that is gears, right? With new chapter, that is gears. Okay, I'll end the meeting. Thank you. Thank you.